We've been dealing with titrations the last couple of days in which we have neutralization reactions between an acid and a base, and that forms a salt and water. So we've been dealing with the molarity of the acid, volume of acid, molar ratio of the base is equal to the molarity of the base, the volume of the base, the molar ratio of the acid. Well, chemists decided that they were going to come up with something that made that calculation a little bit easier. Okay? So we're going to talk today about equivalence. In a neutralization reaction, 1 mole of hydrogen ions reacts with 1 mole of hydroxide ions. That does not mean that a mole of an acid will neutralize a mole of a base. That is not what it's saying. It's saying that 1 mole of hydrogen ions will neutralize 1 mole of hydroxide ions. Now, if you look at these two acids that I have listed there at the bottom, the very first one is hydrochloric acid. The second one is nitric acid. If you are going to list those as monoprotic, diprotic, or triprotic acids, how would you list those? How would you classify those? No, I just said, if just stop and listen to the question, are those monoprotic, diprotic, or triprotic acids? Why? It is correct. They are monoprotic. Why are they monoprotic? Because they only have 1 hydrogen. Excellent, Maddie. So, if I were to ask you, how many hydrogen ions do you think that would have? You would tell me what? 1, because it only has 1 hydrogen, correct? Does that make sense? Can you see that? Monoprotic, only 1 hydrogen there. Only 1 hydrogen there. Now, for other acids, we can have more than 1 mole of hydrogen ions. More than 1 mole of hydrogen ions. So as I'm looking at this particular slide, how would you classify sulfuric acid right here? What, Emily? It is a diprotic acid. So how many moles of hydrogen ion would it have? 2 moles. Why? Because it's diprotic. And how many hydrogens does it have? 2. Phosphoric acid right below it. How would you classify phosphoric acid? A triprotic acid. So how many moles of hydrogen ion would phosphoric acid have? 3 moles of hydrogen ion. Can you see where we are getting at with the moles of hydrogen ions? Now, the same is true of the bases. Only thing is, we're not looking for hydrogen ions. We are looking for hydroxide. What is the hydroxide ion? OH, what charge? -1. So we are looking at the hydroxide ions. So if I look right here, calcium hydroxide, how many OH -1 ions would be involved in that? 2. What about aluminum hydroxide? How many would be involved with it? 3 moles of hydroxide ions. So when we're talking about neutralizations, back to that first slide, it said that 1 mole of hydroxide ions would neutralize 1 mole of hydrogen ions. But does that necessarily mean that 1 mole of an acid neutralizes 1 mole of a base? No. And we'll see that. We'll see that here. Now, I'll give you a second here to get this down. Now, I discussed with you earlier that chemists decided that they needed a unit for the amount of acid and base. This unit would allow them to calculate easier the neutralization values that we were doing with the titration. So they came up with the unit called the equivalent. 1 equivalent is the amount of an acid or base that will give 1 mole of hydrogen or hydroxide ions. So, if I look right here, 1 mole of hydrochloric acid, we stated earlier, hydrochloric acid is a monoprotic acid, so it will have 1 hydrogen ion. Therefore, it is 1 equivalent. Over here, sulfuric acid. We stated that that was diprotic. It would have 2 hydrogen ions, so that would be 2 equivalents. Let's jump down here. Calcium hydroxide has 2 hydroxide ions, so that would also be 2 equivalents. So see how they're comparing equivalents with the number of hydrogen ions and the number of hydroxide ions. Now here is a balanced equation. Would you agree that that equation is balanced? Would you agree that that's a neutralization reaction? Okay. Now, if you look in the balanced chemical equation, it says that 2 moles of hydrochloric acid will react with 1 mole of calcium hydroxide to yield 1 mole of calcium chloride and 2 moles of water. Balanced chemical equation. Now, if you look at it in terms of equivalents, how many equivalents are here? 1, but I have 2 of them. So that's 2 total hydrogen ion equivalents. I only have 1 calcium hydroxide, but each one has how many hydroxides? 2. So that's 2 equivalents of hydroxide ions. So what is actually happening, what is actually happening is that 2 moles of the acid are needed to neutralize 1 mole of the base. All right? Do you remember me telling you when you were balancing equations? Oh, I can see that I have 2 hydroxides here, So I know I'm going to need a number 2 out in front of this one because there's only one hydrogen. Okay, I told some people that to help them try to balance the equations. Right? So, for any neutralization reaction, one equivalent of the acid will neutralize one equivalent of the base. But if I look right here, this base has 2 equivalents. So how many equivalents am I going to need for the acid? 2 equivalents also. Now that brings us to this guy right here, the normality. So when we're looking at normality, okay, normality is based on the molarity. We know that concentrations that we are dealing with here in chemistry are usually talked about in terms of their molarity. We have a 6 molar hydrochloric acid solution, okay, a 0.1 molar sodium hydroxide solution. So we typically talk about their molarity. However, with acids and bases, chemists are more interested in the amount of equivalents. So we have come up with a new value, the normality. The normality of a solution is the concentration expressed in the number of equivalents of solute in 1 liter of solution. Now, copy down this slide, and we're going to talk about this one because it's a pretty important slide. Now, as I look at this top part, okay, as I look at this top part, it says a 2 molar hydrochloric acid solution is a 2 normal hydrochloric acid solution. Why is that the case? Because hydrochloric acid is monoprotic. Okay? Now, let's look at acetic acid. Is acetic acid monoprotic, diprotic, or triprotic? Monoprotic. So, if I take that number, 0.1, times it by 1, I get what? 0.1. There I have it. Look at this guy right here. Phosphoric acid. What is phosphoric acid? Monoprotic, diprotic, triprotic. Triprotic, right? So it has how many? 3. So if I take that number right there, I need to multiply it by 3 to get my normality. Is that what I've done here? What's 0.3 times 3? 0.9. Sulfuric acid. Mono, di, or triprotic? Diprotic. So what am I going to multiply that by? 2. There's my normality. Okay, 0.5. Now you're going to see the same thing with bases. The only thing is you're not looking at the hydroxide ions, you're looking at the, or excuse me, you're not looking at the hydrogen ions, you're looking at the hydroxide ions. Okay? So, for instance, if I would have 0.2 molar calcium hydroxide, what is my multiplier? Okay? What is my multiplier? Well, how many hydroxide ions do I have? How many? 2, right? So that means that would be 2 equivalents. So this would be now, Garrett, what was your question? Yes, but not specifically how you're looking at it, all right? Here's what actually is happening, folks. Okay, if I have a 0.25 molar solution, right? That is really 0.25 moles per liter, right? Now, if I look at sulfuric acid, which is what I'm doing here, okay? I'm dealing with H2SO4. If I look at sulfuric acid, how many equivalents does sulfuric acid have? 2, right? So, what's happening here is I'm taking a mole over an equivalent to get that into equivalence, and that's why I'm multiplying by 2. Okay? Are we assuming we're dealing with what? Well, yeah, because that's what molarity is. Moles per liter.